Hey everyone, today we're going to be talking about vertical shifts. We're actually going to be talking about phase shifts and vertical shifts together as opposed to just focusing on vertical shifts, but a few of our graphs will just be vertical shifts. So we're going to definitely transform some trig graphs today. So let's talk about vertical shifts and what they look like. Okay, so in general, we have our sine equation. And that is y equals a sine of bx minus c plus d. Now the d portion of the equation is your vertical shift. Okay, and it could potentially appear at the beginning or the end. Just remember that it is going to be attached to your function by addition or subtraction. So that's how you know it's not, getting confused with your a value. So in this picture off to the right, you see the graph of y equals sine of x plus 2. It's going to shift your sine graph, which is in red here, up 2 units, and then it just graphs like normal. Right, so that is definitely our example there. So to graph functions with vertical shifts, you can either shift the midline and plot the point pattern with your a, or you can plot the points without the vertical shift first and then move each point up or down based on the d value. I tend to do this one. So let's take a look. Let's do some examples here. We're going to graph one period of each of the following functions. Here's our first one. Y equals cosecant of x minus 1. Okay, so first things first, let's just remind ourselves about cosecant. And all these values. So my a value here is 1, my b value is 1, my c value is 0, and my d value, my vertical shift, is negative 1. Okay, so then 1 period of cosecant is normally 2 pi. Divided by 1, it's still going to be 2 pi. So that's not going to change. We're going to look at just one normal period. So I'm going to put 2 pi here, pi here, pi over 2, and 3 pi over 2. Okay, and then we're going to put, normally we put -1 and +1 on our y-axis, but this time we're shifting down 2 units, so we want to put -1 and -2 on our y-axis. Okay, you can put +1 and +2 if you want as well. All right, so cosecant is the opposite of sine. Your sine graph normally starts at 0, 0. All right, and this hasn't been shifted horizontally, so it's still going to do that, except the only issue is before I start drawing that, we've shifted down 1 unit. So I want to make sure that I shift my sine graph down 1 unit. So that means I would be here, go up, back down to where I started, down to -2, up to -1. So here is my outline of just my little sine graph there. I don't know why it shifted there so much. There we go. Okay, so now remember, for cosecant, whenever we crossed the x-axis, all right, we had an asymptote. All right, well now my x-axis has shifted here. I'm shifting this midline down, -1. So wherever it crosses this purple midline, that is where I'm going to draw an asymptote. And then I draw my curves. So now my minimum of this first parabola is at 0, pi over 2 comma 0. And then a maximum is at 3 pi over 2 comma -2. All right. Next one, 2 cosine of x plus 1. So this time my a value is 2, my b value is still 1, c value is still 0, the d value is +1. So we're going to have an upward shift here. Now the period is still going to be 2 pi because it's cosine. My b value is 1. Okay. So here we go. 0, 2 pi, pi, pi over 2, and 3 pi over 2. Okay, now because my a value is 2 and I'm going to shift up 1, I want to make sure I include maybe 1, 2, and 3 on my y-axis. I can do the same thing. -1, -2, -3 on my x-axis if I want to. Now, my midline, again, has shifted up 1 unit. This is my cosine graph. Normally, cosine starts at 0, 1, right? But we've also shifted up 1, and our a value is 2. So if we hadn't shifted up 1, and our a value was 2, we would start at 0, 2. But let's shift that up 1 more unit to 3. Okay, then we normally go down to our x-axis, but this time our x-axis has shifted up 1, so it'll be right there. And then we go down to, our minimum, which should be 2 units away from our midline, so at -1. Back up to the midline and back up to the top. So here is my cosine function. All right, and then y equals secant of 3x minus 2. So a value is still 1. B value now is 3. C value is 0. D value is -2. A period for this, let's see, secant is normally 2 pi. We're going to divide it by b, so it's going to be 2 pi over 3. So 2 pi over 3 goes here. Half of 2 pi over 3 is pi over 3. Half of pi over 3 is pi over 6, which means this one would be 3 pi over 6, also known as pi over 2. Okay, and we're shifting down 2 units, so we definitely want to include -1, -2, maybe -3 and -4, even if you wanted to go that far, you don't have to. We'll include those two. So 1, 2, 3, -1, -2, -3, -4. Okay, just giving myself plenty of space. So secant is the opposite of cosine. All right, normally cosine starts up at 1, right? And since the a value is 1, that wouldn't change, but I'm shifting down 2 units. All right, so I'm shifting this midline down 2 units. So -1 is actually my new start there. I go down to my midline, down to -3, up to my midline, up to -1. So again, that's my cosine graph there. Remember, every time that we touch that midline, that's my new x-axis, if you will, and creates my asymptote. So half of a U shape will be right here, full U shape right there, and another half of a U shape. Let's do 2 more. So these get a little bit more complicated, a little bit more to deal with. So my a value is still 1 for this one. My b value is 1/2. My c value is pi over 4, and the d value is 1. So it's kind of putting everything together, right? So before we get started on this one, we definitely want to know our period, our phase shift, all that good stuff. So for cosine, the period normally is 2 pi. But when I divide 2 pi by 1/2, keep, change, flip, that's going to become 4 pi. So that's 1 period. Okay, my phase shift, remember, is C over B. So pi over 4 divided by 1/2, keep, change, flip. That will become 2 pi over 4, which reduces to pi over 2. Okay, if I add, 2 pi to pi over 2, 2 pi being 4 pi over 2, oh, sorry. Yeah, if I add, sorry, I'm adding not 2 pi, I'm adding 4 pi, I apologize. So 8 pi over 2. That'll get me 9 pi over 2 for the ending. And then the average of pi over 2 and 9 pi over 2 is going to be 5 pi over 2. So I'll put pi over 2 right here, 9 pi over 2 right here, 5 pi over 2 in between. The in between there is 3 pi over 2, and the in between here is 7 pi over 2. All right, now we have shifted up 1 as well. So if you want, you can put the -1, but then we want +1, we want +2, and we could go up 1 more if we really wanted to, but we don't have to. Now, this is cosine. Cosine normally starts at 0, 1, but we've shifted up 1. So we're going to start at 0, 2. Okay, we can also draw in our midline. Okay, we go down to 1, down to 0, up to 1, up to 2. Oops, sorry. I screwed that one up. I apologize. I forgot I have shifted. Oh my goodness gracious. So not only, whoops, not only have we shifted up, I forgot we also have shifted this way, if you will. So I'm not going to start at 0, 2. I'm going to start at pi over 2, 2. Then down to 0, down to negative, or down to 0, down to 1, down to 0, up to 1, up to 2. So here is my cosine curve that's been transformed. Last one, my A value is 1, my B value is 2, my C value is negative pi over 2, and the D value is 3. Okay. One period of tangent is normally pi, but then I divide that by B, so it's going to be pi over 2. My phase shift, negative pi over 2 divided by 2 is actually negative pi over 4. And then if I add pi over 2 to negative pi over 4, that's going to get me positive pi over 2. So this one's kind of nice and centered on your y-axis. So I'll put negative pi over 4 over here and positive pi over 4 over here. Zero's in the middle of those two. Negative pi over 8 right here and positive pi over 8 right here. Now, I'm going to extend my y a little bit because I want to do 1, 2, 3, 4. I'm going up 3 units, so I definitely want to have that in there. All right, and I've also, shifted over, pi over 4. So that's where my start of my graph is. So normally tangent, when you plug in 0 of into tangent of 0 is 0. All right, but again, we've shifted up 3 units. So at my initial point, it's going to be negative pi over 4, 3. Then we go up to 1 normally. So we're going to up 1. Then we have our asymptote. Okay, then it goes down to negative 1, but my new negative 1, if you will, is 2. And then I go up to 3 again. And then we can draw our curve. So there is our equation, our function graphed. Come to class, ask any questions.